Okay.
Okay, over to you, Weijia.
Okay, thank you, Peter. Hello, everyone. This is Weijia Zhang and Peter Robinson. We are presenting Crosschain interoperability for Ethereum in the Enterprise Asian Pacific Conference. And I am VP of Engineering of OneChain. I'm also co-chairing Crosschain Interoperability Task Force for EEA with Peter Robinson. Peter, to you.
Yes, and hello. I'm Peter Robinson from Consensus Software R&D, and my focus is cross-chain. And I'm also, as we just said, a co-chair of the EEA Cross-Chain Interoperability Task Force. Over to you, Weijia.
Okay, thank you, Peter. We are going to divide the presentation into two parts. I'm going to present the first part about EA and also interoperability task force, and also some of the use cases. And Peter will present the detailed specifications and other works of Crosschain interoperability task force. Yeah, next slide, please. Yeah, about EA. EA is a member-driven organization with the focus on developing Ethereum blockchain standards for not just Ethereum blockchain, but also other blockchains as well. And we have different organizations in this EEA, and also we have different offices in globally. We have China, EA in China, and also in Japan. And yeah, there are many offices as well globally. Yeah, next one. Yeah, and then we all know that blockchain almost developed from grassroots. There have not been good standards for that. We have a Bitcoin, we have Ethereum, and Ethereum has EIP, but there's not a general standard for consortium blockchain and also for industry. So EA, the goal is to develop reference architecture and also standards that can be adopted by EA member companies as well as blockchain industry at large. Next one, please. Yeah. And this is how we operate. First, we have an interest group, and this interest group will gather requirements and some of the requests from member companies. And then we have a task force or a work group to develop some of the reference architecture, some of the architecture design. And then we produce specifications based on the consensus from EA members. And then we develop, implement APIs for these specifications, and then we do it in testnet and provide some certification for these applications or tool set that actually implement the specification. I think certification part is for the future of EA at this time. Next one, please. Yeah, and this is one example of how EA work. If you look at the diagram, the architectural diagram here, the left side is almost the public Ethereum blockchain architecture, where you have a network layer, you have consensus layer, and then the privacy, and no privacy for public blockchain, but then you have smart contract and building up depth on top of that. And what EA does is to introduce enterprise components, which includes performance, privacy, and scaling. These components added to it, and then to make it more enterprise friendly. For example, Consensus and JP Morgan developed the privacy transactions based on Ethereum public blockchain. And now, of course, JP Morgan's Quorum have been acquired by Consensus, then they become one for the enterprise Ethereum blockchain. And then, yeah, the next one, please. Yeah, and then there have been a lot of requests from our member companies. They want to do interoperability. People notice that with more blockchain coming in, with the development of public blockchain and private blockchain, there is a need to bridge them. And so there is a need to develop some standard for cross-chain interoperability. Next one, please. Yeah, so these are the background with the development of public blockchain and private blockchain. There is a challenge and the need for interchain interoperability. And also EA did a survey of its members, and this the interoperability has been identified as a top takeaway by EA members. So we feel that there is a need to develop standards for the cross-chain interoperability. So we propose, yeah, next one, please. Yeah, so we propose a cross-chain interoperability task force to tackle the cross-chain interoperability challenges. And then the goal, the mission statement of CITF is to define and draft specifications, and also to propose and recommend framework and solutions to enable blockchains to function with interoperability, and then to disseminate the knowledge, and also do some actual implementations for the based on the specification we have. Next one, please. Yeah, and these are some of the works we have done, and we are working some work going on. I think it was first proposed in a Seattle meeting, EA Seattle meeting. We proposed that we want to form this group, and then we presented in the face-to-face meeting in Seattle. That's 2019. And then we start to have a bi-weekly meeting for the task force. And then we gather solutions from EA members. This includes solutions from Consensus, Pegasus, and from Kinematics, and also from OneChain, and also gather feedback from other company members as well. And then we start to collect cross-chain interoperability use cases, and this has been done, and we publish a use case document already. And then we also do the architecture, so we kind of add the cross-chain interoperability architecture to the existing enterprise Ethereum architecture. So we're going to show that in the next slide. And then we start to develop more specifications. Next one, please. Yeah, I think I just mentioned that EA is about enterprise. So on the left, on this diagram here, the left side is the public Ethereum blockchain. And then the middle one is the Ethereum enterprise blockchain. And then the one on the right-hand side is a column that's just for cross-chain interoperability. So they need to build many components over there. This including multi-chain tool and maybe even multi-chain consensus for that, and also multi-chain finality. A lot of these things need to be considered, and also there may be some relayers for handling the cross-chain transactions. So we propose this reference architecture for the cross-chain interoperability, and I think this diagram is in the use document that we published. You can look at this diagram from the use document, the use case documents. Yeah, next one, please. Yeah, and this one we also kind of produce a table showing the relationship between different cross-chain interoperability components and different use cases. And some of the components are required for some of the use cases, and some of them are optional, some are recommended. And this is also in that use document that we published. So we can, for detail, we can refer to that one. Yeah, next one, next slide, please. Yeah, and I'm going to introduce, describe a little bit about use cases, right? You may ask, what is the use of cross-chain interoperability, right? So because of time limit, we'll just mention, I'll mention two and transfer to Peter to mention others. For example, you have a cross-chain decentralized exchange. Today, when we do exchange cross-chain, you have to rely on centralized exchanges, right? But with cross-chain technology, you don't need to do that. You can just say that I want to transfer Ether to Bitcoin, and then if there's a kind of buy or sell request, the asset need to be transferred to that address in another blockchain. So with the cross-chain technology, you can do decentralized exchange from for one asset to be transferred to another asset in another platform to another user. So this is what we call the cross-chain decentralized exchange, CDEX. Yeah, next one. And this one is a little bit different. This is called the cross-chain decentralized asset transform. So different from the exchange where you need to change the ownership. For asset transform, you don't change the ownership. For example, today, Ethereum is it's very popular for DeFi, decentralized finance. But with Bitcoin, you cannot do DeFi in Ethereum blockchain. So this asset transform is a use case where you lock the asset in Bitcoin blockchain, and then you generate the same value of Bitcoin on Ethereum blockchain and with ERC20 format, so that you can use that asset to participate in the DeFi applications activities. And that way you can kind of transform the asset in different platform, in different format, to asset in another blockchain, in another format, and participate in the decentralized application activity in that target blockchain. So this is a asset transform. This does not change the ownership of the asset itself. Yeah, okay, next one. Yeah, then I'm going to transfer to Peter to present a little bit a more complex use case and also the specification that we have been working on. Yeah. Yeah, Peter.
Unmute myself. Yeah, thank you, Weijia. Yes, this is a more complex use case involving more than one blockchain. In fact, I've presented it as 5 blockchains, and I'm sure some of you might be thinking, well, maybe this could be done on with fewer blockchains. But so I'll walk through the example. So you have a externally owned account, and they want to submit a transaction to say some goods have arrived, let's pay for them, and as well we need to pay at the current price. So they have maybe a multi-signatory wallet that is on a blockchain, and we want to keep the membership of that wallet private. And so the various participants of the consortia need to maybe sign into that wallet to say, yes, we can execute the trade. So then you do execute the trade. And then maybe due to government authorities, the actual business logic around calculating prices has to be made public. So that terms blockchain may have to be shared with a government regulator as well. And so the business logic sits on that logic blockchain. And so the shipment function calls get price from the Oracle blockchain. So the Oracle blockchain might be run by a company that publishes prices of commodities that can be trusted, but maybe you have to pay for access to that blockchain. And so they might say sell access rights to that data. And so you get the value from that blockchain, and then you pay, so you transfer the value from one user to another in the finance blockchain, and you transfer the ownership of goods in the logistics blockchain. And now, as I've said, you can imagine that maybe you could bring some of these blockchains together, and so you would not have as much requirement for cross-blockchain communications. But we've had several examples around the world of you'll have a consortium of banks and other financiers who will be wanting to be on the finance blockchain, but they do not want to be on the logistics blockchain. And the people on the logistics blockchain are shipping companies and such like. And so you will find that you will have the participants involved in, there is obviously overlap, but you will have different sets of participants in each of those blockchains. And hence you'll have 2 separate enterprise blockchains, and you'll have the requirement to be doing cross-chain transactions between those 2 chains. In addition to the 3 use cases that Weijia and I have talked about, there are many, many, many other use cases. So we have that use case document, which I suggest you read through, and you'll be able to see all of these other use cases. We're working on specifications as well. So the cross-chain ID specification explains the format and usage of an identifier which uniquely identifies any public or enterprise blockchain. And that's important when it comes to things like discovery, so that then you know which blockchain you're interacting with and what the properties of that blockchain might be. Cross-chain consensus are a set of mechanisms for providing trust between blockchains. So if you get a value from one chain onto another chain, how can you trust that value? And so we're working on standards around how do you do that trust. Atomic swap mechanisms is useful for situations in which you want to swap an asset on one chain for an asset on a different chain. Cross-chain function calls provide a richer mechanism for doing arbitrary application logic across multiple blockchains. So we're still working through the systems and the standards. And so we're working through the taxonomy, and I think there's more to be done there. Working out on, there will be different layers of interoperability. And so we need to be cognizant of the various standards that we create and allowing people to be, say, compatible at certain layers and potentially not compatible at other layers, but then offering ways of creating that compatibility. We are going to be working on these various specifications over the coming months. And so at the moment, we hope to have some initial standards out there for the actual identifier and the consensus and the function calls and the swaps in 2021. So the governance has been established of the task force has been established by the board of directors of the Ethereum Enterprise Alliance. And so that's how we're governed. We also have involvement and have had involvement from Brittany and Charles. They're very active. And then additionally, Sarah Feenan, previously from Clearmatics, was heavily involved in the group in the past. And I believe, yep. So that is the end of the slideshow. And so thank you for joining us. And if you have any questions, please be in contact.
Yep, thank you. Yeah, thank you.
All right. So thank you and see you later. And